1M Number 1. This was the very first attempt by any nation to reach Mars. Launched by the Soviet Union in October 1960, the mission was a flyby probe designed to send back images and data. It never had the chance. The third stage of its Molniya rocket failed just minutes after launch, and the probe was destroyed before ever reaching Earth orbit. 1M Number 2. Just 4 days after the first failure, the Soviets tried again with an identical probe and rocket. The result was the same. The second launch attempt also suffered a third-stage failure, and the spacecraft was lost. These first two shots were a stark demonstration of the immense difficulty of just getting off the planet. 2MV4 Number 1, the Soviet Union's third attempt at a Mars flyby, launched in October 1962. This mission made it one step further, successfully reaching a parking orbit around Earth. However, when the upper stage was supposed to fire to send the probe on its path to Mars, it exploded. The spacecraft was destroyed, raining debris back down into the atmosphere. Mars 1. This was the first mission to achieve a partial success. Launched by the Soviets just a week after the Sputnik 22 failure, Mars 1 successfully escaped Earth orbit and began its long journey to the Red Planet. For over 4 months, it sent back valuable data on the interplanetary space environment. But on March 21, 1963, when the probe was over 60 million miles from Earth, its antenna orientation system failed and communication was permanently lost. It flew silently past Mars, a ghost ship that proved getting there was only half the battle. 2MV3 Number 1. This Soviet mission, launched in late 1962, was an even more ambitious attempt to land a probe on the Martian surface. Like its predecessor, it successfully reached Earth orbit, but the upper stage again malfunctioned. It failed to achieve escape velocity and broke apart, with its pieces eventually re-entering Earth's atmosphere. Mariner 3. This was NASA's first attempt to go to Mars. Launched in November 1964, the mission was a flyby probe designed to take the first close-up pictures of the planet. The launch itself went fine, but the protective shroud, or fairing, covering the spacecraft atop the rocket, failed to jettison properly. Trapped inside this shell, the probe's solar panels couldn't deploy for power, and it was unable to achieve the correct trajectory. It ended up in a useless orbit around the Sun. Mariner 4. The mission that changed everything. Launched just 3 weeks after the failure of its twin, Mariner 3, NASA's Mariner 4 performed flawlessly. On July 14, 1965, Mariner 4 flew past Mars and returned 21 complete images, plus 1 partial frame, the first close-up pictures of Mars. The grainy black and white images revealed a cratered moon-like surface, which shocked scientists who expected a more Earth-like world. It was a monumental success that gave humanity its first real look at the Red Planet. Zond 2. Launched by the Soviet Union in late 1964, this was another flyby probe that successfully began its journey to Mars. However, like Mars 1 before it, it suffered a fatal technical failure en route. After a mid-course correction maneuver, one of its solar panels failed, cutting the spacecraft's power in half. Communication was eventually lost in May 1965, and it too flew silently past Mars. Mariner 6, the first of a new, more advanced pair of NASA flyby probes. Launched in February 1969, Mariner 6 was designed to fly much closer to Mars and carry far better instruments than Mariner 4. It successfully flew over the planet's equatorial regions, sending back detailed photos and data on the Martian atmosphere and surface composition. 2M Number 521. This was the Soviet Union's ambitious attempt to send a heavy orbiter to Mars using their powerful new Proton rocket. Launched in March 1969, the mission ended in a fiery disaster. The rocket's third stage failed hundreds of seconds into the flight, and the powerful probe was destroyed. Mariner 7, the twin to Mariner 6, launched in March 1969. Mariner 7 successfully flew past Mars just 5 days after its sibling, but focused on the southern hemisphere and the polar cap. Together, the data from Mariner 6 and 7 provided a much more detailed, though still incomplete, picture of a cold, cratered, and inhospitable-looking world. 2. M number 522. Just 2 weeks after the first Proton rocket failure, the Soviets launched their second heavy orbiter. This mission ended even more spectacularly. A failure in the first stage caused the rocket to explode just 41 seconds after liftoff, completely destroying the vehicle, the spacecraft, and severely damaging the launch complex. This ended the Soviet Union's attempts to beat the Americans to orbit in the 1969 launch window. Mariner 8. This was the twin to the successful Mariner 9 orbiter and NASA's first failure in the second wave of exploration. Launched in May 1971, the Centaur upper stage of its Atlas rocket malfunctioned, sending the vehicle tumbling out of control. The rocket and its precious cargo were destroyed, falling into the Atlantic Ocean just minutes after liftoff. Kosmos 419. This was the Soviet Union's last-ditch effort to beat the Americans to Martian orbit. Launched just 2 days after the Mariner 8 failure, this heavy orbiter successfully reached a parking orbit around Earth. However, a simple but catastrophic human error doomed the mission. The timer for the Block D upper stage, which was supposed to fire and send the probe to Mars, was set incorrectly, programmed for 1.5 years instead of 1.5 hours. The stage never fired, and the would-be orbiter burned up in Earth's atmosphere. Mars 2. A Soviet two-part mission consisting of an orbiter and a lander. In November 1971, the Mars 2 orbiter successfully entered an 18-hour orbit around Mars and returned data and images, though the global dust storm limited what it could observe. The lander component separated, but its descent system also malfunctioned. It entered the atmosphere at too steep an angle and crashed onto the Martian surface, becoming the first man-made object to impact the red planet. Mars 3. The twin to Mars 2, this mission achieved a historic, if fleeting, success. The orbiter successfully entered its planned orbit and conducted science for months. Its lander became the first spacecraft to achieve a soft landing on Mars on December 2, 1971, a monumental achievement. But its victory was short-lived. It transmitted a partial, garbled image and then fell silent after just 110 seconds, its mission cut short by a colossal planet-wide dust storm that was raging at the time. Mariner 9. After its twin, Mariner 8, was lost, NASA's Mariner 9 had to take on the objectives of both missions. Arriving in November 1971, it successfully entered orbit, beating the Soviets by a few weeks to become the first spacecraft to orbit another planet. It arrived during the same global dust storm that killed the Mars 3 lander. Mission Control patiently waited, and as the dust cleared, Mariner 9 revealed a stunning, completely new Mars. It returned thousands of images and mapped about 80% of Mars's surface, revealing Valles Marineris, the Tharsis volcanoes, and major ancient channel systems. Mars 4. Part of a 4-probe Soviet assault on Mars in 1973. This mission was designed to be an orbiter that would serve as a communications relay for the landers. On its approach to the red planet, a computer chip flaw caused the main retro rockets, needed to slow the spacecraft into orbit, to fail to fire. As a result, Mars 4 flew right past the planet in February 1974, taking a few unusable pictures as it went. Mars 5. The second of the 1973 Soviet flotilla, Mars 5 was another orbiter. It successfully entered orbit around Mars and operated for a few weeks, collecting valuable data and images to help identify landing sites for its companion landers, Mars 6 and 7. However, its mission was cut short after just a few orbits, when a crack in the pressurized instrument compartment caused it to fail. Mars 6. This mission consisted of a flyby bus and a lander. The lander successfully separated and began its descent through the Martian atmosphere. It transmitted atmospheric and engineering data for about 224 seconds during descent before contact was lost. It is presumed to have crashed. Mars 7. The final probe of the 1973 Soviet campaign, Mars 7 was also a lander. It failed even more spectacularly than its predecessors. A malfunction in its onboard systems, likely due to a faulty computer chip, caused the lander to separate from its bus too early and at the wrong angle. It completely missed the planet by over 800 miles, flying uselessly past it. Viking 1. The first of two monumental NASA missions that would define our understanding of Mars for decades. Viking 1 consisted of a powerful orbiter and a sophisticated lander. It entered orbit in June 1976, and after careful site selection, the lander successfully touched down on July 20, 1976. It transmitted the first high-resolution panoramic images from the surface, monitored the weather, and conducted biology experiments designed to look for life. The lander operated for over 6 years. Viking 2. The identical twin to Viking 1. It entered orbit in August 1976 and deployed its lander in a different location in September. Like its sibling, the Viking 2 orbiter and lander were a resounding success. Together, the two Viking missions provided a detailed global map and long-term climate data, revealing a cold, dry, volcanic world. Their biology experiments returned tantalizing, but ultimately ambiguous, results that are still debated today. Phobos 1. The first of two highly ambitious Soviet probes designed to explore Mars and its strange moon, Phobos. After a successful launch and start to its journey in 1988, the mission was lost due to a catastrophic human error. A ground controller uploaded a single, incorrect command that deactivated the spacecraft's attitude control thrusters. The probe began to tumble. Its solar panels could no longer point at the sun for power, and contact was permanently lost. Phobos 2. The twin to the ill-fated Phobos 1, this ambitious Soviet mission successfully reached Mars in January 1989. It entered orbit and spent several months collecting valuable data on the planet's atmosphere and magnetosphere. As it began to maneuver closer to its primary target, the moon Phobos, in preparation for deploying two landers, the spacecraft's onboard computer failed. Contact was abruptly lost, and the mission ended just before it could achieve its main goal. It was the last planetary mission of the Soviet Union. Mars Observer. This was NASA's first mission to Mars in 17 years, a large, powerful orbiter designed to be a climate and geology surveyor. After a flawless 11-month journey, just 3 days before it was scheduled to enter Mars orbit in August 1993, the spacecraft abruptly fell silent. An investigation concluded that a rupture in the fuel pressurization system likely caused the spacecraft to spin uncontrollably and break apart. Its stunning loss solidified the myth of the great galactic ghoul said to devour Mars probes. MGS. The mission that represented NASA's triumphant comeback. Designed as a smaller, cheaper replacement for the lost Mars Observer, MGS successfully entered orbit in 1997. For nearly a decade, it mapped the planet in stunning detail with its high-resolution camera and laser altimeter, creating the first precise global maps of Martian topography. It revealed ancient riverbeds, deltas, and gullies, providing definitive evidence that water once flowed on Mars, and providing the data that guided all subsequent lander missions. Mars 96. Russia's first interplanetary mission after the fall of the Soviet Union. This was a hugely ambitious and complex mission, consisting of an orbiter, 2 landers, and 2 surface penetrators. Launched in November 1996, the powerful Proton rocket's fourth stage malfunctioned. The massive spacecraft failed to escape Earth orbit and came crashing back down, breaking up over the Pacific Ocean. Its failure was a devastating blow to the Russian space program. Mars Pathfinder, the mission that reignited public passion for Mars. Landing on July 4, 1997, Pathfinder successfully tested an airbag landing system and deployed Sojourner, the first rover to operate on Mars and the first robotic rover on another planet. Sojourner was only the size of a microwave oven, but its success was monumental. The mission's stunning images and the public's ability to follow the rover's journey online made it a global phenomenon, proving the viability of roving exploration and a new, faster, better, cheaper approach for NASA. Nozomi, Japan's first interplanetary mission. Launched in 1998, Nozomi was plagued by problems from the start. A faulty valve caused a major fuel shortage, forcing the probe to take a much longer 5-year gravity-assisted route to Mars. During this extended cruise, it was damaged by a massive solar flare. After a heroic multi-year struggle to save the mission, engineers determined there was not enough fuel left to enter Mars orbit, and the probe was commanded to fly past the planet in 2003. Mars Climate Orbiter, perhaps the most infamous failure in space exploration history. This NASA orbiter reached Mars in 1999, but as it prepared to fire its engine to enter orbit, it descended too low into the atmosphere and burned up. The cause was a catastrophic but simple software error. One engineering team at Lockheed Martin used imperial units for navigation calculations, while the NASA team used metric units. The unit mismatch sent the $125 million spacecraft to its doom. Mars Polar Lander / Deep Space 2, a double failure that capped a disastrous year for NASA. The Mars Polar Lander was designed to study the Martian South Pole. In December 1999, it was lost without a trace during its descent. The final cause is believed to be a software flaw that prematurely shut down its landing engines while it was still high above the ground, causing it to crash. Riding with the lander were two small experimental penetrators called Deep Space 2, designed to slam into the surface. They were never heard from either. 2001 Mars Odyssey, the mission that broke the curse and became the longevity champion of Mars orbiters. Arriving in late 2001, Mars Odyssey's primary mission was to map the chemical composition of the surface. It famously discovered vast deposits of subsurface water ice across the planet, a resource critical for future exploration. It is still operational and has long served as a crucial UHF communications relay for Mars surface missions as part of the broader Mars Relay Network. Mars Express, Europe's first and highly successful mission to another planet. Arriving in late 2003, the Mars Express orbiter has been studying the planet's atmosphere and geology ever since. Its MARSIS radar has probed beneath the south polar layered deposits and detected bright basal reflections that some researchers interpret as hypersaline liquid water beneath the ice, a finding that remains actively debated. It also carried the ill-fated British lander, Beagle 2, which successfully landed but failed to deploy its solar panels, preventing it from ever communicating. Spirit, the first of two beloved twin rovers that became a global phenomenon. Landing in Gusev Crater in January 2004, this golf cart-sized robotic geologist was tasked with following the water. Designed for a 90-day mission, Spirit explored for 6 years, climbing mountains and discovering evidence of an ancient, violent past of volcanoes and hot springs. It became stuck in soft soil in 2009 and served as a stationary science platform until it finally fell silent in 2010. Opportunity, the second of the twin Mars exploration rovers. Landing on the opposite side of Mars from its sibling, Opportunity hit the scientific jackpot immediately, touching down in a small crater with exposed bedrock that showed clear evidence of having been formed in liquid water. Designed for 90 days, it operated for an astonishing 14.5 years, traveling over a marathon's distance and fundamentally proving that ancient Mars was a wet, watery world. MRO, NASA's High-Resolution Eye in the Sky. Arriving in 2006, MRO's camera, HiRISE, is the most powerful ever sent to another planet, capable of resolving features on the surface the size of a dinner table. Its mission is to conduct detailed reconnaissance, scouting for future landing sites, and studying Martian geology. It has revealed a surprisingly dynamic world, capturing avalanches, dust storms, and recurring slope lineae that are now widely interpreted as dry granular flows rather than flowing briny water. It also serves as a critical high-speed data relay for rovers on the surface. Phoenix, the first and only mission to land in the Martian Arctic. In 2008, this stationary lander was sent with one primary goal: to touch the water. Its robotic arm successfully dug into the ground, scraping up and analyzing samples of bright white water ice, providing the first direct ground truth for the vast ice deposits detected from orbit. It also studied the polar weather and discovered perchlorate chemicals in the soil, which have implications for both past habitability and future human exploration. Fobos-Grunt / Yinghuo 1. This was Russia's highly ambitious attempt to return to Mars and perform the first ever sample return from its moon, Phobos. The mission ended in a humiliating failure. After a successful launch in 2011, the spacecraft became stranded in low Earth orbit when its main engine failed to fire for the burn to Mars. It circled the Earth silently for 2 months before crashing back into the Pacific Ocean. Lost with it was China's first Mars probe, the small Yinghuo 1 orbiter, which was hitching a ride. Curiosity, a 1-ton, car-sized, nuclear-powered mobile chemistry laboratory. Landing in Gale Crater in 2012, Curiosity's mission was not to find life, but to determine if Mars ever had the right environmental conditions to support life, a concept known as habitability. Using its powerful suite of instruments, its key discovery was definitive. Its landing site was once a long-lasting freshwater lakebed with all the chemical ingredients and energy sources necessary for life as we know it. Mangalyaan, India's first interplanetary mission. Launched in 2013, Mangalyaan was a stunning technological triumph, designed and executed on a remarkably small budget. It successfully entered Mars orbit on its first attempt, making India only the 4th entity in the world to do so. While it carried a small suite of science instruments to study the atmosphere, its primary success was as a technology demonstrator, proving India's capability to conduct deep space missions. MAVEN, NASA's atmospheric specialist. The MAVEN orbiter arrived in 2014 with one primary goal: to study how Mars lost its once thick atmosphere and abundant water over billions of years. Flying in an elliptical orbit that dips deep into the upper atmosphere, its findings have confirmed that the sun's solar wind stripped away the planet's protective atmosphere after its magnetic field shut down. ExoMars 2016, a joint European-Russian program that was a story of 2 parts. The Trace Gas Orbiter successfully entered orbit and is performing its mission to map the Martian atmosphere for rare gases like methane, which could be a sign of active geology or even biology. Its companion, the Schiaparelli lander, was a technology demonstrator that crashed on the surface due to a sensor and software error during its descent, which caused it to shut off its engines too early. InSight, the first mission to study the deep interior of Mars. Landing in 2018, InSight was a geophysical lander, not a rover. It stayed in one place to measure the planet's vital signs. Its hypersensitive seismometer detected hundreds of Marsquakes, allowing scientists to map out the planet's crust, mantle, and surprisingly large liquid core for the first time. It effectively gave Mars its first ever medical checkup. Hope, the Arab world's first interplanetary mission. Arriving in 2021, the Hope orbiter was a major achievement for the United Arab Emirates. It is not a geology mapper, but a dedicated climate and weather orbiter. Flying in a unique high-altitude orbit, it is designed to build a global picture of Martian weather and climate across different local times of day and seasons. Tianwen-1, China's first Mars mission, and a stunningly ambitious, all-in-one success. Arriving in 2021, Tianwen-1 entered orbit, then released a lander which successfully touched down and deployed the Zhurong rover. The combined orbiter, lander, and rover mission made China only the second nation to successfully operate a rover on Mars, a massive technological and political statement of its spacefaring capabilities. Perseverance, NASA's most advanced rover. Landing in Jezero crater in 2021, Perseverance's primary mission is astrobiology, to actively seek direct signs of past microbial life in an ancient river delta. It is also the crucial first step in a Mars sample return campaign, collecting and caching the most promising rock cores for a future mission to retrieve and bring back to Earth. It also carried the Ingenuity helicopter, which performed the first powered, controlled flight on another world. Next generation. The exploration of Mars is set to continue with a new generation of innovative missions. NASA's Escapade twin smallsats launched in November 2025 and are planned to arrive at Mars in 2027 to study the magnetosphere and atmospheric escape from 2 vantage points. Mars sample return is still being pursued as a NASA and ESA effort, but its architecture, cost, and schedule are being reworked, so the follow-on sequence and timing are not currently firm. In the same vein, China is planning its own ambitious sample return mission, Tianwen-3. And awaiting a new launch plan is the European Space Agency's Rosalind Franklin rover, designed to drill 2 meters beneath the Martian surface to search for signs of life, deeper than any rover has gone before. Thanks for watching. If you had to pick one Mars mission to send next, would you go after life, samples, or human landing prep? Let me know in the comments. Also, please remember to like and subscribe if you enjoyed this video.